All right. Hey guys. So again, now we're going to look at today is we're going to look at a two-step equation. We did one last week where we used the inverse, but now we're going to do a two-step equation. Our goal does not change at all. It's the same exact goal. So our goal is to either isolate the variable, right? Remember, isolate just means get by itself, or like I said, get the variable alone. It's fine. Get the variable alone, get the variable by itself, however you want to say it. We just want to make sure we get the variable alone. All right. So regardless of what we're going to do, it's the same idea every time. All right. So first of all, instead of having just one thing to do, we're going to have two steps this time. So one, it's not the only thing you can do, but the best thing to usually do is we're going to get rid of whatever's being added or subtracted. All right, so we're going to get rid of addition or subtraction first. We're going to get rid of the non-variable number. So whatever's being plus 7, minus 5, we're going to get rid of the non-variable first. All right, and second, we're going to get rid of multiplication and division. Feel free to abbreviate if you can't fit in there. I know I made the spaces kind of small. So feel free to abbreviate there. It's not a big deal. All right. So these are the steps you want to go back to. Isolate the variable, get it alone, get rid of addition or subtraction, the non-variable, and then get rid of what's the variable. All right. So we come here. So let's look at the first example. So I'm going to put my lines in. All right. Again, this is my idea of saying what side. So my question is x by itself? And no, there's a -3 and there's a 5 there. All right, so I need to get rid of both the -3 and the 5. So the question is, what do I get rid of first? Now, it doesn't matter. There's a way to get rid of the -3 first, but then it deals, everything's in fractions. It gets kind of ugly. So we're going to get rid of the non-variable first. So here's our non-variable, a plus 5. What's the inverse of plus 5? All right, so again, remember inverse, the opposite, all right? It's an idea, but what's the inverse of plus 5 is minus 5. Whatever we do on this side, we do on this side. All right, so the 5's cancel out. I bring my -3x down. My equal stays in the middle. And now I have 2 minus 5, or 2 and a -5. So either way, I have positive 2 and -1, 2, 3, 4, 5. All right, these cancel. I'm left with -3. So now I get back to a one-step equation. Is x by itself? No. You just made fun of me the way I said that. I know you all are. You're like, it's okay. It's all right to make fun of me. I'm okay. So here, I want to get x by itself. Is it by itself? No, there's a -3 there. Remember when I see this, that means times. So what the inverse of times is division. So I'm going to divide by -3 on both sides. So -3 divided by -3 is 1, which is just x, equals -3 divided by -3 is 1, and that's my answer. I can check it. I can say -3 times 1 plus 5, which is -3 times 1 is -3 plus 5, which is 2, which is what I wanted. So I know I'm right. There's my answer. All right. So again, the idea is get rid of the variable, the non-variable first, then get rid of the one that's the variable. All right. So go ahead and press pause, try B, and then come back when you guys are done. All right. So again, I come back here. I know I made this kind of small. -5. The inverse is plus 5, plus 5. All right. These cancel out. I'm left with 2x equals -9 plus 5. All right, if I did a quick number line down here, here's -9. Plus 5 means I go that way. All right, so I'll be at -4. 2x means times again, so I divide by 2, divide by 2. X is equal to -2, and that's my answer. All right, so let's move down here. Again, don't let the fractions freak you out. And some of you are going to look at this and go, "Oh, it's fractions. I'm so bad." Forget it. You're okay. Relax. Take a deep breath. All right? I know all of you had nightmares over fractions last week, and I'm sure you're okay. All right? So now again, All right, I'm going to do this, forget the fractions, I'm just going to look at the numbers. Is my x alone? No. So how do I get rid of a minus 1/2? What's the inverse? It's plus 1/2. Both sides. These cancel out. I bring my x over 8 down, equals negative 7/2, or negative 7 over 2, or negative 7/2, plus 1/2. I'm going to come down here. I'm going to say negative 7 over 2 plus 1 over 2. They're the same denominator, so I keep that the same. Negative 7 plus 1 is negative 6, so that's negative 3. Negative 6 over 2 is negative 3. Negative and positive is negative. 6 over 2 is 3. So I look at this. This means division, so I can rewrite it. X divided by 8 equals negative 3. I'm not doing the inverse. I'm just rewriting. What's the inverse of division? Times 8 times 8. So I get x equals positive and negative is a negative. 3 times 8 is 24, and I'm done. And I can check it and see if it works. 24 over 8 is 3. Sorry, 24 over 8 is 3. 3 minus 1/2 is 2.5. Sorry, negative 3.5 is negative 3/2, and that's what that equals to. All right? So, try D on your own. See how you do. Pause it now. All right. So we come back in. I say minus, inverse is positive, 8.2 plus 8.2. I get 5x because this cancels out. This becomes 12.5. All right, this means times. What's the inverse? It's division. So I divide by 5. X equals, and I go, I don't know. Again, think what this is close to. This is really close to 10. 10 divided by 5 is 2. All right? Or you can say this is really close to 15. 15 divided by 5 is 3. So my answer has to be between 2 and 3. So I can come down here and just say, okay, 12.5 divided by 5. Top number on the inside, bottom number on the outside. So 5 goes into 12 twice. 2 left over. Bring down my 5. My decimal place stays in the same place. I really don't need it there. I'm sorry. 5 times 5 is 25. I get 0. So my answer is 2.5. Remember, you can use a calculator. So take advantage of having a calculator and see how that goes. All right? But what I want you to realize as we go through all this, it's not really different. It's just the same thing we're doing, just combined, having 2 steps instead of 1 now. All right? So, other side. This is where it gets a little weird looking. I look at E, and I go, okay, that's strange. All right? But again, 3x minus 5x, I don't have to get rid of this. They're both the same terms. All right? So they're like terms. So this is where I can sit there and say, okay, this is 3x, this is negative 5x. They're on the same side. I don't need to move them. That's just negative 2x. All right? They're like terms. It's just what I did a couple weeks ago. They're on the same side. I can just add them up. They're like, so it's negative 2x equals 12. So when you see this, don't think it's anything special. Don't think it's anything different. All right? Just make sure you always collect like terms. All right? So this just becomes a one step. I divide by negative 2, divide by negative 2. X is going to equal negative 6. All right? So try F. See how you do. All right. So now what we're going to do is we're going to add these two things up. I have a negative 9x, positive 12x. All right, remember, use your strategies. Number line, something. So if I owe someone $9 and I have $12, it means I'm going to have 3x equals 15. This is where I'm going to speed up a little bit. Divide by 3, x equals 5. And I'm done. All right? Now, a word problem. This is where it gets a little weird. All right, so these word problems are tough. Hopefully you can read this a little bit. All right, so again, let's just put the pencils down for a second. Let's just read the problem. The height at the top of a roller coaster is 10 times the height, which is called h, of the starting point. The height decreases 100 feet from the top to the bottom of the hill. The height at the bottom of the hill is negative 10 feet. Find h. All right? So now we're just going to kind of look at this and kind of figure out what's going to happen. All right? So let's read the first sentence. The height at the top of a roller coaster is 10 times the height of the starting point. All right? So I can look and say, okay, what's the top? All right, the height at the top of the roller coaster is 10 times, well, that's easy, that's 10 times, the height of the starting point, which is called h. So that's 10 times h. So that first sentence, 10 times h. I don't know what h is. I don't have to do any math. I'm just going to rewrite that. All right? Second sentence, the height decreases 100 feet from the top to the bottom of the hill. And I go, okay, so I just know it decreases 100 feet. All right? So decreases 100 feet. And that means subtract 100. I mean, that's what decreases means. All right? It means subtract. The height at the bottom of the hill is negative 10 feet. Find h. So the bottom of the hill is negative 10 feet. All right? So the bottom at the bottom is negative 10 feet. I want to know what h is equal to. All right? So now we want to figure out what h is. All right? So we don't really know what h is. So that's what we're going to figure out. We want to know what h is. All right? I do know that the top is 10 times h, and to the bottom is negative 100. I know the height from the bottom is negative 10 feet. All right? So take a couple seconds, see if you can figure that out. Oh, hold on one second. All right? So again, see if you can write an equation for that. All right? So now we want to make sure we can just see if we can make an equation for that. All right? All right, so what's going to happen is we're going to sit there and say, well, the height of the bottom is negative 10 feet. So we're going to say, okay, that's equal to negative 10. We know the top is going to be 10h, and we subtract 100 to get there. And so there's my equation. Now I can solve it. Plus 100, plus 100. This cancels out. 10h equals, this ends 90. 10 times h means time, so I divide both sides by 10, and h equals 9. And that's my answer. All right? Sorry about that. So again, it's a little bit, it's a little complicated. Again, these are kind of problems that we're going to have to see a lot of, and that's where it gets a little confusing. All right? So see how it goes. Let me know. When we switch here in a second, we'll talk more about the word problems as we go along. If you see this right here, these are the answers to the homework on the other side. So when you do the homework tonight, you can check your answers here. All right? So we're about to switch, so let's talk after that. All right.